Hello, my name is Munir Hasham. I am a PDX core study director at the Jackson Labs, research scientist, and also I am an educator for several cancer courses at the Jackson Labs. So today I'm going to talk to you about the basic cancer biology. What is cancer? How do we get cancer? But mostly I will be talking to you about cancer itself. What is cancer? How do we think as scientists about cancers, and how do we go on for to try to discover new drugs? So again, I'm at the Jackson Laboratory, and which has been in existence since 1930s, and has been a frontier of cancer research and other types of research, including COVID right now. So, what is cancer? Cancer is a disease that is characterized by uncontrolled growth of cells of a particular tissue. So, for example, if a normal cell inside the brain starts growing without control, it becomes cancer, brain cancer. Cancer comes from a Greek word. It's called carcinos. When the ancient Greeks saw the first types of tumors, which was breast cancer, they opened it up and it looked more like a surface of a crab. So they called it carcinos, or as we know now, cancer in English. Below is a picture of a mouse that has leukemia, that is from my lab. We have mice with different types of leukemia, and we can visualize in 3D in order to find new drugs. So, between a cancer cell versus a normal cell, there are several different things, and we're going to explore each one of these individually, right? It shuts off growth suppressors, it hides from the immune system, it metastasizes, it uses inflammation to hide from the immune system, it builds vessels, it metastasizes, as I said, it mutates, it also blocks cell death, and it increases its own metabolism. So this is known as characteristics of a cancer cell. And I'm going to go through the specifics of each one of these. This was published a while back by these two scientists, Hanahan and Weinberg. There are other versions of this out there. Take a look, but this is the most basic way I could explain cancer to you. So let's get started. Cancer shuts growth suppression and turns on cell division signals, right? So a cell, imagine this yellow ball is a cell, and it's giving you, there are signals that come to it that says grow, start dividing. So one cell becomes two cells becomes four cells becomes 8 cells. When it's reached the maximum amount that it naturally has to be, it will release, these cells will release these blue things that I've drawn here, known as receptors, and then there's a cap that come, an inhibitor that come in and actually blocks this, and the cell stops dividing. Cancer blocks these blue things; it doesn't express it, or it will go ahead and turn on the division signal, so it grows without control. And then, next thing, inside a cell, there is a cycle, right? The cell usually is in something called a G1 state. And then it will synthesize its DNA in the S phase. And then it will go to a G2 phase where it begins to think about dividing or prepare for dividing. And then it will go through an M phase where it might undergoes a process known as mitosis. And two different cells will come from one cell. That's how normal cell division works. Now, at each one of these points in time, there is a pause signal to check the DNA of the cell, to check, because you don't want bad DNA, bad cells to proliferate, correct? So in cancer cell, these pause signals are gone. So there is no pausing to check the DNA. The cancer cell with damage will keep on dividing. And that produces even worse effects. The third thing that the cancer cell does is it hides from the immune system. Those blue blobs you see, those are cancer cells, and the green is a T cell from your body. So T cell will find a cancer cell and it will poke a hole and put that red stuff, the red toxin, it's poison. It will stick it in the cancer cell and kill it. So cancer cells have found a way around this. One, it produces receptors that exhaust the T cells, and then it has inflammation. It would produce factors that has inflammation around the tumor so that the immune system thinks, oh, okay, I've already solved this, and it will get blocked. So inflammation and exhausting the T cell makes the cancer cell survive the immune attack. And then after that, the cancer cells, once it grows into a tumor, it tells the body to build blood vessels to it. It literally instructs the rest of the body to be their slave, right? So it will build this. This process is known as angiogenesis. So tumors will build blood vessels, and then it will use these blood vessels to get fresh supplies and also to use it as a way to metastasize to other organs. So one of the worst things is actually metastasis, right? Metastasis is what makes cancer worse. I mean, if it's set in one spot, we'll do surgery and we can get to it. But when it starts building these growth vessels to itself and starts metastasizing everywhere, then we have a serious issue, because then it's harder to cure something that is everywhere instead of a localized place. Then what cancer uses is mutation. So your DNA inside your cell is protected. And I listed all these repair systems that are inside the DNA to protect it. Now we get damage from UV radiation, from bad habits, from spontaneous, like in Maine, for example, we have a lot of radon in the ground. So we get all that, but the cell is protected. There are all these repair mechanisms that sit and repair the DNA inside the cell. But a cancer cell will damage or disrupt these systems in order to keep a mutation. Now you'd say, why a cancer cell wants to do that? Yes, it wants to do that because it wants to keep evolving faster than what your immune system or your natural system can adopt. So cancer cells, one way to evade the immune system is to keep mutating. And the last thing here is cancer cells have faster metabolism. They metabolize faster and they use inefficient processes to actually metabolize. So for example, the Warburg effect, which is glucose, which we use in all our cells, becomes glucose 6-phosphate and into pyruvate. Now in normal cells, this will go into the Krebs cycle, which is normally producing a lot of ATP and normal system. Cancer cells will use a fermentation. They will not use the normal cycle and produce lactic acid. And this is inefficient, but it's way faster, right? We produce lactic acid. You'll feel it in cramps in your legs sometimes, but not to the extent cancer cells will do. So, here in summary, I've shown you all the different ways that a cancer cell is different from a normal cell. Now, one of the things we do when we study this is we try to find the ways to block what cancer is trying to do. So, for example, if a cancer cell shuts off the cell death systems, then because it doesn't die, right? We find things that would block that, so it will end up dying, right? If it's using faster metabolism, we give the cancer anti-metabolomics, which is something that will block the fast metabolism. And we keep trying every day, every moment to study these things and find ways to counteract it. Thank you for listening.